What is going on, you guys, and welcome back to the channel. In this video we're going to be looking at Pytest. Now Pytest is a free and open source testing library for Python. It has a very simple syntax which of course encourages a lot more usage of the library and very easy to use. So in this video we're just going to go over how to get up and running with Pytest and the sort of cool functionality that comes with this testing library. So in order to get started, first we need to go ahead and install Pytest. Now already I've created an empty Python environment and a Python project. So I've just used pip. I'm using pip as my installer. Feel free to use whatever you want. But to do this, I'm just going to say pip install and then Pytest. And then the version I want to use is today's date is 7.1.3. So that's the current version of Pytest. However, if you're watching this in the future, it may be something a bit different. Just hit enter and it should now have installed. Now to check that Pytest is installed, you can just do Pytest, then -h, and you should get the following results. So it's basically all the sort of helper tools that you need with Pytest. And if you don't, if you get an error, then Pytest hasn't been successfully installed, but it's just a standard pip installation. Alright, so for the example, that we're going to use for testing is that of shapes, basically. So I'm going to go ahead and create a new Python package. I'm just going to call this shapes. And inside that, I'm going to create a new Python file, so inside our shapes directory, and call this rectangle. Alright, and now this is just going to be this class is just going to represent a standard rectangle. So with this, we're going to have in it, and it's going to take in a width and a height, and then we're just going to set width to being width, the height to be height, and then let's add some functions that we'll later then test. So the first one is going to be one that calculates the area. Now for this, we'll just do return self.width times self.height, and that will calculate the area for us. Another one would be the perimeter, and for that, it will do return self.width times 2. So let's just wrap this in brackets, plus self.height times 2, and again just wrap that in brackets. Alright, so now we have two methods for our rectangle class, area and width. The other one we could add is square, and that will check to see if a given rectangle is a square. So here we'll just say return self.width equals self.height, and yeah, that's pretty much it for our rectangle. The other thing we want to make sure is that the width and the height is a value greater than 0, because a rectangle cannot have a value in the negatives or a 0 value. So for that, let's just go ahead and add an if statement. So if width equal or less than 1, or height is less than 1, we want to raise an error, so we'll just raise a value error here, and we'll say the width and height must be greater than 0. Alright, so now we just have like a quick check in our initializer to make sure that the values width and height are greater than 0. Alright, so this is pretty much our rectangle class, nothing too fancy. It just has a few methods for calculating the area and the perimeter, and another method that checks to see if it is a square or not. Now for our Pytest, now this is where we actually get into the testing part. To do that, I'm going to create a directory called tests, and that's typically what you would do when creating Python tests in general. So I'm going to go to new, and then Python package. I'm using PyCharm, by the way. You can of course use whatever one you want, but here I'm creating a Python package called tests, which comes with this init file. And with Pytest, when you want to create a test file, you have to mark it, you have to name it so it includes either the word test at the beginning of the file or test at the end. So for example, you could have test underscore rectangle like so, or you could have a rectangle underscore test. Now I typically prefer the test to come first, so I'm just going to go with that. Test underscore rectangle, hit enter, and now we have our test file. So again, Pytest will pick up those files that have the test either at the word test either at the beginning of the file or at the end of the file. It'll also pick up those folders or directories that have the word test in it. So we're all good here. All right, so let's first go ahead and import Pytest. We'll need that later on, and then we'll say from shapes dot rectangle import rectangle. All right, so let's first create a test function that will test the area of a rectangle. We'll do test underscore rectangle underscore area, and here we'll just say rectangle equals rectangle, and then we'll give it a width of 10 and a height of 4. Now for this, the area we know will be 40 because width times height. Here 10 times 4 equals 40. So we can just go ahead and say assert rectangle dot area equals 40. Okay, so now to run this, what you need to do is in the terminal, and I'm in the project itself, so the Pytest tutorial directory, that's the name I've given it, and you just have to type in Pytest and then tests and then test underscore rectangle. Hit enter, and you can see here that it's collected one item referring to our test rectangle area function, and that has passed. So there's green, it's saying here as well, one passed in 0.01 seconds. So, and it gives you the percentage of all the tests that have passed. But now, for example, if I set this to 30, and if I run this, we get one failed, and it gives us the assertion and it tells us what's going on. So here you can see assert 40 equals 30, where 40 is there, and it was expecting 30. And we get this fail here. And yeah, so that's what a failure could look like. So let's set this back to 40. Next, let's go ahead and do the same for our perimeter. So we'll say test underscore perimeter, test rectangle perimeter. And then here we'll say rectangle equals rectangle, give it a width again of 10 and a height of 4. And then we can assert rectangle dot perimeter equals, and that should be 28. Now I can run this as well. So if I go back to my command line, just clear it and do Pytest and then tests and test rectangle. Now it's collected 2 items because it's referring to the 2 test functions that we've added, and both have passed as it states here. And you can see these little dots here, these green dots, to signify that we have 2 tests that have passed. All right, so also another thing, if you are using PyCharm, I think there's also an extension for VS Code where you can have this functionality, but you have this green play button, which you can use as well. So if I click play on this one, it will test that individual test function. And yeah, so you can use that as well as a helper one. However, I'll just use the command line for now, as it's a bit more agnostic when it comes to teaching you guys. All right, so we have now 2 functions for our perimeter and area. Let's go ahead now and create one for our is square. Now we'll say test rectangle is square. And here we'll create a rectangle equals rectangle, and we'll set the width to 10. So just give it some easy numbers, and height to 10. And then we'll say assert rectangle dot is square. Now this assertion, which I don't think I went over earlier, all this assertion is saying is just checking for a Boolean value. So in this case, it's saying assert. So it's asking the computer, does the whatever value we put in after the assertion, does it evaluate to true? And that's essentially what this does. So here we can say assert rectangle is square, and then we can say, and we can just leave it at that actually, because is square returns a Boolean value if we go back to our method that we defined for rectangle. So now I can go ahead and run this. So I'll say Pytest and then test rectangle, and it's collected 3 and all have passed. Let's go ahead and do one so that test rectangle is not square. And sorry if I'm becoming a bit repetitive with the test that I'm writing. I just want to make sure this sinks in for you guys. Let's go ahead now and say rectangle. We can go ahead and copy this rectangle over here. And we'll say rectangle with a width of 10 and a height of 4. And we'll assert rectangle and then is square. But given that this is not a square, we have to put a not at the beginning and say assert not rectangle is square. Now if we go ahead and run this again, we get back 4 passes, and that's that. All right, so if we go back to our rectangle class, if you remember in the initializer, we created this raise value, or that we created this error raise, where if the width or the height is less than 1, then we'll get a value error. Now, if we were to go ahead and create a new test, let's say test rectangle, just create something very basic, and then I did something like rectangle equals, and then rectangle, we'll give it a width of, let's say, -4 and a height of 5. If I were to run this now, we get back 1 fail. That's because Pytest will fail on anything that raises an error. So in this case, it's raised a value error. Now, there are many cases when it comes to writing tests that you also want to check for errors. So you want to make sure that something is raised given some sort of input. And we can do that quite easily with Pytest. Now, to do that, first, let's go ahead and just rename this. We'll say test error negative width, just to give it an appropriate name. Then we can say width, and then Pytest, which we imported at the beginning. So this import Pytest. So with Pytest, and then dot raises, we can then type in what we want to make sure is raised. So this is the value error. And then inside that, we can just say that we get a value error if we were to do anything underneath that. So again, all this is saying is whatever's underneath this, or whatever's in this block of code underneath this with statement, that a value error occurs at some point. So now, if we run this, we get 5 passes, and that's just to make sure that a value error is present. However, if we were to give it a different error, like a key error, we should expect a fail, because in this case, when the width or the height is negative, we always get a value error, and we do. We're getting an error here because it expects a value error, and we're checking for a key error. So we'll just say value error again, and it's back to where it is. Now we can go ahead and do the same thing for test error on a negative height. Say with Pytest dot raises, inside that value error, and then a rectangle. We'll give the width a positive value such as 4, and the height we'll give it a negative value of 10. And now if we were to run this, we get back 6 passes, as in this case as well a value error is raised. Now that's pretty much, so right now we've just gone ahead and covered the typical assertions, so this typical checking to make sure that a certain Boolean evaluation occurs. So in this case, area equals 40. And then we've also gone ahead and done some tests around errors. So in this case, we're checking to make sure a value error occurs whenever we initialize a rectangle with a width or height in the negative values. So now we'll go ahead and look at something called fixtures. So with fixtures, what they allow us to do is feed some data into the tests that we write. So for example, it could be some input data such as a rectangle, and we'll go ahead now and look at how useful they can be. They also encourage some code reuse inside our rectangles, inside of our tests, sorry. So for example, if we look now at our test rectangle file, we can see that we repeat this rectangle quite often with the same width and height. So we've done it once, twice, and yeah, 3 times. So instead what we can do is create a fixture out of it. Now to create a fixture, you first have to create a decorator or use this decorator called Pytest.fixtures or fixture. And then underneath that, you can create a function that will return some value or do something to some data. Now here we'll just call it my rectangle. You can name it whatever you want. And all we'll do here is return a rectangle with width of 10 and a height of 4. Now, in order to use this fixture, all we have to do is write it as a parameter inside of the tests we want to use it in. So we can say something like my rectangle here, and then we can go ahead and remove this and say my underscore rectangle dot area equals 40. So that's how you can make use of a fixture. It's very simple and also cleans up a lot whilst you're using it. The other thing is we can also use it here in our test perimeter. So we can say my rectangle again and remove this, and then just replace this rectangle dot perimeter with my rectangle dot perimeter. And notice as well that we're not calling this function, we're just stating it without calling, we're just writing the function name without calling it, and that's how you can make use of them. Then where else do we use it? We use it here in this is not square, so we can say my rectangle, and then here we can just remove that and say my rectangle here as well. So now if we go ahead and run this, so we do Pytest and then tests and test rectangle, we get back all passes, and all we've done is created this fixture called my rectangle. We can do the same thing as well. We can say with square, so Pytest raise fixture, and say square, and we'll just say return rectangle, and we'll create a width of 10 and a height of 10. Now if we go to the test functions that make use of this, so here we could do square and just remove this, and we can say here square dot is square, and I think that's pretty much it. But if you were to have more tests, you can see how useful this becomes. Let's go ahead and run this, and we get 6 passes as well. So that's how you can make use of fixtures. Now one thing I just want to highlight as well is we have this test library. Let's say we were to create another shape. So for example, let's create a new one called circle. Now for our circle, we'll just say, and this will, I'm not doing this just to waste time. I want to show you something in a second. We can go ahead and say, so we'll say, underscore init, and this will take in a radius, and let's go ahead and say self.radius equals radius, and then we'll do area, which will just return self.radius, which is pi, so we'll do math.pi, and that's just imported it from the math library. Actually this is incorrect, we should just do, it's math.pi times self.radius squared, so pi r squared. And yeah, so now we have our circle one, and now if we were to create tests for our circle, create a new file, call this inside our test directory, test circle, we can just say import Pytest and then create a fixture. So we'll say Pytest.fixture, and this will be circle, and we need to import that from shapes. So we'll say from shapes dot circle. That circle spelled wrong as well, but never mind. So now we'll say return circle and then radius. We'll just give it a radius of 10. Now we can go ahead and create let's create a very basic function. I don't want to overload this one because we've gone through a few of them. So test circle underscore radius, and we can pass in our circle here, and we can just say assert circle dot area equals circle dot radius squared, and then we just need to do math dot pi times that, and let's just quickly import math like so. So now if I were to run that file, I can do Pytest and then tests circle, hit enter, we get one pass. If I want to test all of the test files inside our tests directory, all I can do is say Pytest and then tests like so, and it will run test underscore circle and test rectangle along with any other file that is marked with a test with has the name test in it and the test functions inside it. And again, the functions as well have to have test at the beginning. That's how Pytest picks it up. Okay, so that's with fixtures. Now, what if, for example, inside our test rectangle, for some reason, we want to make use of our circle fixture that we added in test underscore circle. Now, one way to do that is using this thing called conftest. Now, a conftest just allows us to use fixtures all throughout our tests module. So here, I'm just going to go ahead and go conftest like so as a Python directory. And inside that, I'm just going to do, I'm just going to copy over our Pytest fixture from circle, or just cut that over. And in here, I'm just going to say paste like so. And then I'm just going to import Pytest like so. And from shapes.circle, import circle. And also rectangle, as we will need that from shapes as well. So from shapes.rectangle, import rectangle. And let's go ahead and move over our fixtures to that as well. So I'm just going to take this, and then in the conftest, I'm just going to import that or paste that in. So now it has to be named conftest in order for us to use this in other files. So if we go back to the test underscore circle radius, we still have this circle, but because we have it in our conftest, we can still reuse it. So let's just go ahead and run Pytest tests and then test underscore circle, and we still get a pass. No issues are brought up. That's because this circle is coming from our conftest, and it has to again be named conftest.py, and this just allows us to share our fixtures among different tests. Now we can also make use of circle inside our rectangle. So for example, let's say that let's have like a pretty dumb test that just says, for whatever reason, I don't know why this would actually be a test, but we can say test rectangle area bigger than circle area. And here we can say rectangle or my rectangle and circle like so. And I think this will pass. So assert my rectangle dot area is greater than circle dot area. To be honest, I didn't actually test this, so I don't know if the rectangle's area is bigger or not. But if I run now Pytest tests and then test underscore rectangle, we get a fail. I think that's because the area of the circle is a lot bigger. So we can just rename this circle area bigger than rectangle area. and we can say that the rectangle area is less than the circle area. But the point I'm trying to demonstrate here is that we can now use our circle fixture inside our rectangle test, and we can also use our, and vice versa, we can use our rectangle fixture inside our test underscore circle. And the way to do that is to create a conftest.py file inside our test module, and then define the fixtures that you want there. So that's pretty much how you can make use of fixtures as well as conftest, so we can share fixtures around your test files. The next thing now is to look at how to parameterize tests. So with parameterizing tests, what that allows us to do is that it allows us to define multiple sets of arguments and also fixtures for our test functions. So to create a parameterization, so to do that, let's go ahead and let's change up our area, our test rectangle area. Let's create a new one, but this time we want to give it a bunch of different values so we can test the area function on different values. And if that's still a bit unclear, I'll show you in a second. So we'll say test multiple rectangle areas. So that'll be the name of our test, and we'll just put pass for now. Now to parameterize this, again, we'll make use of our Pytest decorator. So we'll say Pytest and then .mark, like so, and then parameterize, spelled like this. Okay, now we have to give it some values. So the first is going to be a width, and then we're going to comma separate it. Then we're going to have a height, and then we're just going to have our expected area, like so. Then we're going to have a list that will correspond where each item, a list of tuples basically, where each item in the tuple will correspond to width, height, and expected area based on the order we've defined it. So for example, width we'll give it a 10, and then we'll give the height 10, and then we'll give the expected area 100. Then we'll create another one. So for another rectangle, we'll say 4, 5, and 20. So again, width will be 4, height will be 5, and expected area will be 20. And then for our final one, let's add our third one, 2 for our width, height as 1, and expected area as 2. All right, so next we have to then plug these with the width, height, and expected area as parameters to our test function. So to do that, we'll say width, like so, and then height, and then expected area, just like that. Now let's go ahead and create our test. So we'll say assert, and then a rectangle, and we'll pass in the width, we'll pass in the height, and then we'll say area equals expected area, like so. All right, so let's go ahead and run this, and we'll say Pytest, and then tests, and then test rectangle. And now you can see we have 10 tests that I've run. So 10 tests have passed. The other 3, the new 3 have come from this. So each one reflects one test. So for the values where the width, height, and expected area are 10, 10, and 100, that's one test. Then another one, 4, 5, and 20. And for the last one, 2, 1, and 2. We can keep adding more if you want to, but essentially that's how parameterization works. It just allows us to define multiple sets of arguments for our function that we can then use to test a certain piece of functionality, in this case, the area. Now you can go ahead and try it out for the perimeter, for example, to test that with parameterization. That would be a nice way to kind of really understand and digest what parameterization does. It's super powerful. In this example, of course, we're using a very basic class, which is rectangle. But if you were to look at this for more complex applications, this really does allow us to be a bit more cleaner, and it does also save time when it comes to writing tests. All right, so that's how parameterization works. Now we'll go ahead and look at how we can mark our tests. So to do that, and by marking, it basically means if you look at how we've been writing our commands in the terminal, so we've been doing Pytest and then test underscore rectangle.py. You can also clean that up a bit and make it a bit more nicer to kind of input. So if you go right to the top of this file of our test underscore rectangle file, you can say Pytest and then mark and set that to Pytest and then dot mark and then name whatever you want. So in this case, I'm just going to call it rectangle. Now what we can do is if we go back to our terminal, instead of saying Pytests and then test underscore rectangle.py, we can instead say Pytest and then -m and then rectangle, like so. And what that will do is just test our it basically just refers to this test file. It's just a bit nicer to read and nicer to input as well. Now the other thing I want to show you is how you can skip tests. So skip tests, what that just allows, it's like a nice easy way of, let's say you have a test but you don't want this test to run right now but you still want to keep the code. What you can do is just say Pytest and then .mark and then .skip. Now that will just skip that test. So if we go ahead and run this now, you can see here that we've got a 1 skipped, and that's just saying that this test is not going to be run. We're just going to go past it, and that's it. Alright, so that pretty much brings us to the end of our section for parameterizing tests and also using skip. Next we'll look at how you can create classes or class-based tests rather than functional-based tests using Pytest. So far we've been writing our tests the functional way. For example, if you look at our test underscore rectangle, all of our tests have this test underscore and then the name of our test. And again, just to clarify or to repeat a very important point, is that our test functions have to have tests at the beginning. But so far all of these have been function based. Now there's another way to write it, and that's doing it the class way, and we'll use our circle class for that. So we'll test circle class. So to do that, it's very simple. All you have to do is say class and then test, and you have to have test at the beginning of it, and then the name. So we'll say test circle. Now here we can just take our, say, test underscore radius, and we can still make use of our fixture, our conftest fixture, our global fixture if you like. And let's just go ahead and move this over to our test radius. And that's pretty much it. That's all you have to do when it comes to creating a test suite. Now, of course, you also get the benefits of having it in a class as well. So in some cases this can be useful. For example, if you want to create a common test that other tests will inherit from, that could be useful. For example, we could have a class test shape, which both rectangle and circle could inherit from, that will always have test area, and this should be called area. So for example, that could be some of the benefits. Alright, so again, let's just kind of add a bit more meat to our circle. Let's say inside our circle class, we'll also have a if statement that will check if the radius is less than 1, then we want to raise a value error, and we'll just say the radius, like this, the radius must be greater than 0. And then inside our test circle, this suite, I think that's the term for it, for a class-based one. So we can just say something like def and then test negative radius, and then we can do something like width and then Pytest dot and then raises. We can say value error, and then we'll just say we also need our circle import, so from shapes dot circle import circle, and say circle radius equals -5. And now to run this, all we have to do is say Pytest and then test circle, and we get 2 tests because inside of our test circle we have those 2 tests. Now just for completion, we can say Pytest mark and set this to Pytest.mark.circle, just like we have circle spelled correctly, just like we have with our rectangle. And now we say Pytest-m and then circle, and that works just as before. All right, so that's how you can create a test class, and rather than having it the functional way. Most of the time, in like the way I've seen it, especially in my professional career and in other kind of pieces of code, is that most people tend to write functional tests. However, there are of course different use cases when it comes to writing tests the functional way or the class-based way. It really depends on your preference and also the use case. But that brings us to the end of this video. So we've gone over the different sorts of functionality that comes with the Pytest testing library. And yeah, if you found this video valuable, please leave a like, comment, and also subscribe. And I hope to see you in the next video.